Before we start working on circle theorems, it is important to know how to identify specified angles. If I ask you to identify angle A, would you be able to show me where angle A is? Will it be this letter? Will it be this point? Of course not. This is the vertex A, so we label this point as A to identify where these two lines, this is line CA and this is line BA. So line BA, or really a line segment BA, and line segment CA meet at this point. We call this point a vertex. So that's the vertex A. And when two lines meet at a vertex, an angle is formed. So because the vertex, we refer to it as A, then the angle, we also call it angle A. While we can say this is angle A easily, it might be difficult to do that when we have a different scenario. Let's see. Can I say that this is still angle A? Perhaps we could, but the only thing is, someone would use the same reasoning and consider this to be angle A as well. That these two lines, this line DA from going from D to A, and the line which goes from what? Point C to point A, right? So these two lines, DA and CA, meet at the vertex A. So the angle formed here is angle A. So we consider this to be angle A and this to be angle A. Well, someone else might use the reasoning that, hey, these two line segments, line segment BA and line segment DA, meet at the vertex A as well. So this line segment DA and line segment BA form an angle between them, which is angle A, because they meet at what? At the vertex A. So you see, we have three angles that we can see having a vertex A. And so we want to use letters to identify which of the angles we're talking about. And by the way, this symbols the two straight lines meeting at a point, so we can say that's angle. Angle BAC. We're talking about going from B to A and then from A to C. So we're talking about this angle between these two lines here, this line segment BA and line segment CA. So that we're talking about this angle here. Let's identify this as little a. So it's equal to the value of A degrees. Let's say we make this one B degrees, this angle here. So we can say angle, let's say we want to go from C to A to D. So we can say angle C, A, D. And so we're going from what now? We're going from C to A to D. So use a different letter, different color. So we're going from C to A and from A to D. So we're talking about which angle? Well, the angle formed between those two lines, between these two lines here. Going from C to A and from A to D, we're talking about this angle here. So when we say CAD, angle CAD, we're talking about angle B, the small b there. Notice that I'm using this notation to mean angle, as well as this one also, right, to mean angle. So like a hat. Okay, and also I can also use a different notation, the word angle itself. Angle BAD. So angle BAD is going from B to A, and then from the vertex A to the vertex D. So we're talking about this larger angle here between the two lines, between line segment BA and line segment AD. Okay, I can say line segment AD or DA, we're talking about the same line segment. So between line segment BA and AD, we have angle BAD. And that will be the sum of these two angles. Angle A plus angle B, small b. Okay, so these two angles, small letter angle A, small letter angle B, would actually give us the larger angle, which is angle BAD, going from B to A to D. Now, I hope that helps. Now, if it didn't help you too much, let's have some practice. Let's go some practice. All right, so let's look at angle CBD. Going from C to B to D. So the angle formed between these two lines is the angle I'm looking for. Well, the thing is, I don't have the measurement. We don't have a small letter to represent the angle. But what we do know is that that angle is coming from what? A triangle. If you look at the fact that we have a triangle, we have a triangle. We can start at any letter. We can, let's say B. We can say triangle BCD. That's this triangle here. I know in any triangle, the sum of the three angles add up to what? 180 degrees. The sum of the three angles add up to 180 degrees. So if I know this angle is 30 degrees, I know this angle here is 70 degrees, then what is this angle here? Well, I know the three angles of any triangle add up to 180, so to find the third angle, I'll take from 180 the sum of the other two, being 30 degrees plus 70 degrees. And this will give me 180 degrees minus 100 degrees. And that is actually 80 degrees. So if I add up 80 degrees to the sum of 30 plus 70, which is 100 degrees, I'll in fact get 180. Just checking. So going back to this, here we have a triangle in triangle BCD, right? We have triangle BCD, and I know the two angles here being R degrees and S degrees, but I want to find this third one, so it'll be 180 degrees minus the sum of the other two. Okay, and I kind of simplify that, so I leave it as it is. So this angle here, angle CBD, going from C to B to D, is actually 180 degrees minus the sum of the other two, whatever those are. All right. Angle BAE, going from B to A to E, will be what? Angle BAE, going from B to A and A to E. Well, that will be the angle between the two lines. Angle between the two lines, line BA and AE. And you can see that this angle here is divided into two parts, being angle what? X degrees plus Y degrees. So that will be X degrees plus Y degrees. When I add them up, I get the complete angle, BAE. Let's look at angle BAC now. Angle BAC, going from B to A to C. That's going from B to A to C. And we're talking about this angle here formed between these two lines, line BA and line AC. Line BA and AC. And that angle is angle X. Let's look now at angle ACE, which is going from line AC to line CE. Line AC to line CE, and this is line CE. And the angle formed between these two lines, highlighted, is N degrees. That's the angle. Let's look at ACB now, going from A to C to C to B. A to C. So A to C, going from A to C, and then C to B, that'll be this angle right here, angle M. Next we're gonna have AC going from A to C and C to D. Going from A to C and C to D. So let's be these two. Look at the lines I'm connecting it to. From A to C, which is this line, and from C to D, which is this line. So we connected the two, we tied the two lines together. All right? So that's the angle. So we're looking at angle M plus angle R. What's the next one? The next one is angle BCE. We're going from B to C, or from C to E. So looking at these two. Angle BCE. So looking at angle N plus angle M. Alphabetical order, angle M plus angle N. Next one, BCA. Going from B to C to A. So it'll be these two lines here. I'm tying together. Lines BC and line CA. BC, CA. With this little angle here, which is angle M. Now if you look at it, you know that we have two angles being equal to angle M. So we have this angle being the same. Why is that? We're seeing that angle ACB is the same as angle BCA. The middle letter is the same, but when we switch the letters around, we still get the same angle. Why is that? I notice that the symbols we're using for angle is different. This is the angle symbol, and there's a little hat, which also uses the angle symbol. Well, if we're going from A to C to B, let's look at it. We're going from A to C to B, and we got M. We got this. We're from A to C to B. It's the same thing as going from B to C to A. We still got our angle M. So it doesn't matter. So angle ACB is the same as angle BCA. The middle letter is the important one, and the other two letters can be switched. Now, if we look at angle BAC, we've seen it's X. B to A to C is angle X. We're going from C to A to B is still X as well. So the starting point being B in one instant and the starting point being C in another instant doesn't matter, because the middle letter is what we're looking for. So CAB or BAC is still X. We're talking about the same two arms or legs of the angle. This is one arm and this is another arm of the angle BAC. These are the answers. You can double check them.